leveling effect. Suppose we have water in 3 different beakers. We add in first beaker HCl, in second beaker HBr, and in third beaker hydrogen iodide. By adding these 3 different acids in water, can we compare their relative acidic strength? Can we tell that which acid is stronger and which acid is the weaker one? Whether HCl is stronger or HBr is stronger or HI is stronger, which one is relatively stronger as compared to the others? By dissolving these acids in water, we cannot provide any information of their relative strength. This is called as leveling effect. Leveling effect means all different acids seem to be of the same acidic strength when they are dissolved in water. If their acidic strength is comparable, like HCl, HBr and HI, these 3 are strong acids. So when we will add these 3 strong acids in water, they will be of the same level with respect to their acidic strength. They will be of the same level. So that's why it is called as the leveling effect. Why? Because in all these 3 cases, HCl will protonate water and it will produce H3O positive and Cl negative. Similarly, HBr will also equally protonate water to produce H3O positive and Br negative. And similarly, hydrogen iodide also equally protonates water, producing the same amount of H3 positive and I negative. So by dissolving these 3 strong acids in water, we cannot provide any information of their relative strength because they appear to be of the same level with respect to their acidic strength. That is called as the leveling effect. So now what should we use in order to check their relative acidic strength? We will have to use some relatively weak base, and that weak base that usually used is the acetic acid. So now separately, not in the same mixer, please listen carefully, separately dissolve HCl, HBr and HI in acetic acid. Acetic acid is relatively a weak base as compared to water. Water is amphoteric and carboxylic acids are also amphoteric in nature. So now, in order to protonate acetic acid is not as much easier as it was to protonate the water. So in this case, the stronger acid will protonate acetic acid more and the weaker acid will have lesser capacity to protonate the acetic acid. So in this way, in order to find their relative strength, we will have to use some weak base as compared to water, so that it must be quite difficult for the acids to protonate it, and a stronger acid will more protonate the acetic acid and a weaker acid that will less protonate the acetic acid. So by dissolving these 3 acids separately in the acetic acid, we can find their relative strength. Now HCl will protonate acetic acid, producing CH3COOH2 positive plus Cl negative. Similarly, HBr will also protonate acetic acid, but not in the equal capacity as the HCl was protonating, and it will again produce CH2 positive plus Br negative. And in case of HI, when it will protonate, it will again protonate up to different extent. depending upon its acidic strength. H2 positive plus I negative. So these three acids will protonate in the different capacity to this acetic acid. So the different amount of this conjugate acid will be produced. In this case, different amount will be produced, and this will tell their relative acidic strength. And when we check their acidic strength in water, their acidic strength appears same. HCl, HBr and HI, they are of the same acidic strength when they are dissolved in water. But when they are dissolved in acetic acid, their actual strength is found, and which shows that HI is the strongest, then that is HBr, then that is HCl. So in this way, leveling effect means that when you dissolve any strong acid in the water, they will appear of the same level with respect to their acidic strength. And in order to find their actual acidic strength, we will have to use some weak base as compared to the water. And one of the weak bases that we have selected here, that was the acetic acid. So this was all about from the leveling effect. Take care.